we want to take a look now at the idea of the chain rule. The chain rule is actually extremely important because up to now we've been taking derivatives like ddx of x squared equals 2x. But what happens if I have a situation where I don't have an x squared? Suppose I need ddx of some function of x, maybe x squared plus 3x plus 1 all to the third power or something like that. It's similar to this, but how do we deal with all this inside here? Well, what I'm talking about here are composite functions. So we want to find the derivative of composite functions, and we're going to use what's known as the chain rule for that. Now, we also want to find the derivative of a function using what's known as the general power rule, and really that's just an application of the chain rule. And find derivatives of trigonometric functions using the chain rule. So those are the main key things for the next several videos that you want to kind of keep an eye on. So let's start off with a theorem here. If y equals f of u is a differentiable function of u, and u equals g of x is a differentiable function of x, then y equals f of g of x, there's my composite function I was talking about later, this guy right here is actually a composite function, is a differentiable function of x, and dy dx, the derivative of y with respect to x, remember u is a function of x, equals, this should be a y, dy du times du dx. So this is like taking the derivative of my original function with respect to u and then multiplying that by the derivative of u with respect to x. Now that may have seemed like a mouthful, and I guess in a way it kind of is. It's very common. I hope you do see this is a y here. That's not supposed to be an f. But it's very common for this type of notation the first time you see it to give you a bit of a headache. It's not necessarily all that clear. But what this amounts to mechanically is right here. The derivative of f, which is a function of x, or a function of g of x, so I have a composite function, equals f prime of g of x. I think of this as a derivative of the outside. That's what this is right here, times g prime of x, which is the derivative of the inside. Because g of x was inside this function. So it's a derivative of the outside times the derivative of the inside. That's a very common way to think about it. Now, in reality, you've actually been using the chain rule for quite some time now. You just don't realize it. If I said take the derivative ddx of x squared, you'd say, oh, that's pretty easy. That's simply 2x. Well, it is. But you know what you just got done doing is ddx of x squared, see now this is some function of x in here, equals 2 times x, times the derivative of the inside, this is inside, that's x prime. Well, what's the derivative of x? That's just 1. So this is 2x times 1, which is obviously just 2x. It's because every time we end up with this 1, previously, because we weren't dealing with composite functions as such, that we never even mentioned this idea, and we never even bothered with that 1. We just said, well, there it is. But in reality, there's an x prime sitting there that is actually the chain rule.